Hi guys, I'm Lynn Valerie Custodio. So for this video is we're going to interview some IT students in CTU regarding of their topic, digital logical design, which is the subtopic is flip-flops. So let's go. So I have here an IT student. She's a first year. So I'm gonna ask her about the flip-flop. So what is flip-flop?
Flip-flop is a circuit that maintains a state until directed by input to change the state. A basic flip-flop can be constructed using 4-NAND or 4-NOR kits. Flip-flop is popularly known as the basic digital memory circuit. It has two states as a logic 1 high and logic 0 low state. Flip-flop is a sequential circuit which is consists of a single binary state of information or data. The digital circuit is a flip-flop which has two outputs are of opposite state. It is also known as visitable multivariable.
So can you give me the types of flip-flop?
SR flip-flop, GK flip-flop, D flip-flop, D flip-flop.
So we have found an IT student, one IT student. So I'm going to ask her questions. So as an IT student, what is our flip-flop in regards of digital logical design?
SR flip-flop. It is a flip-flop with two inputs. One is S and the other is R. S here stands for set and R here stands for set. Set basically indicates set the flip-flop, which means output 1. And reset indicates resetting the flip-flop, which means output 0. Here a clock pulse is applied to operate the flip-flop. Hence, it is a clock flip-flop. Flip-flop is a term that comes under digital electronics, and it is an electronic component that is used to store one single bit of information. Then, since flip-flop is a sequential circuit, so its input is based upon two parameters. One is current input and other is output from previous stage. It has two output. Both are complement of each other. It may be in one of two stable statements, either or 0 or 1.
Okay. I've already done asking the SR flip-flop, and I'll be asking someone, an IT student as well, in regards of its basic block diagram of SR flip-flop, its function, its truth table, and its working. So can you discuss about the basic block diagrams, its working, truth table, and function?
So, basic block diagram of SR flip-flop. The basic block diagram contains S and R inputs, and between them is clock pulse. Q and Q inversion is the complemented outputs. Okay. Working of SR flip-flop. Case number 1. Let's say S equals 0 and R equals 0. The output of both AND gates will be 0, and the value of Q and Q inversion will be same as their previous values, such as hold state. And case number 2. Let's say S equals 0 and R equals 1. The output of both AND gates will be 1 and 0. Correspondingly, the value of Q will be 0 as one of the input is 1 and it is a NOR gate. So, it will ultimately gives 0, hence Q gets of 0 value, and similarly Q will be 1. Case number 3. let's say S equals 1 and R equals 0, then output of both AND gates will be 0 and 1. Correspondingly, the value of Q will be 0 as one of input to NOR gate is 1. So output will be 0. Ultimately, in this 0 value will go as output to upper NOR gate, and hence Q will become 1. And the last, case number 4, let's say S equals 1 and R equals 1, then output of both AND gates will be 1 and 1, which is invalid. So the output should be complement of each other. Table of SR flip-flop. S is the set input, R is the reset input, Qn plus 1 is the next state, and state tells in which state it enters. Function table of SR flip-flop. S is the set input, R is the reset input, Qn is the current state input, and Qn plus 1 is the next state outputs.
So I have found another IT student. So I'm gonna ask her regarding the characteristic equation of SR flip. So what is characteristic equation of SR flip-flop and its excitation table?
So the characteristic equation SR flip-flop tells us about what the next state of flip-flop in terms of present state. In order to get the characteristic equation, key map is constructed, which will be shown as below. So if we solve the above key map, then the characteristic equation will be Qn plus 1 equals S plus Qn. And for the excitation table, basically it tells us about the excitation which is required by flip-flop to go from current state to next state. Here, Qn is the current state. Qn plus 1 is the next state outputs, and SR are the set and reset inputs respectively.
So, can you discuss me about what is GK flip-flop?
It is one of the essential logic circuit which store binary information in bitwise manner. It consists of two inputs and two outputs. Inputs are set G and reset K, and their corresponding outputs are Q and Q. GK flip-flop has two modes of operation, which are synchronous mode and asynchronous mode. In asynchronous mode, the state will change with the clock CLK signal, and in asynchronous mode, the change of state is independent from its clock signal. The GK flip-flop represents the basic structure, which consists of clock, CLK, blur, CLR, and preset PR. Below is the circuit of GK flip-flop. Two 3-input NAND gates are used in place of original 2-input AND gates. The outputs of Q and Q are coupled and each gate's third input. Since the two inputs are now interlocked, the SR flip-flop cross-coupling enables the previously invalid conditions of S equals 1, then R equals 1 to be employed to perform the toggle actions. In a circuit, set the button NAND gate interrupts the G input coming from the O position of Q in the reset states. The stop NAND gate interrupts the key input coming from the position of Q. We can use Q and Q to control the inputs. Then, because they are always different, the flip-flop is toggled according to the truth value when both inputs G and T set to 1.
So can you discuss me about the operations of GK flip-flop and its race around condition?
So, version of GK flip-flop given below is the version of GK flip-flop is case number 1, PR equals C, LR equals O. So, this condition is MH invalid state. So, case number 2, PR equals O and CLR equals 1. The PR is activated, which means the output and the Q is set to 1. Therefore, the flip-flop is in the set state. So, case number 3, PR equals 1 and CLR equals 0. The CLR is activated, which means the output and the Q is set to number 1. Therefore, the flip-flop is in reset state. So case number 4, PR was CLR1. In these conditions, the flip-flop works in its normal way, whereas the PR and CLR gets deactivated. So next, race around condition in JK flip-flop. When JK and K both are state to 1, the input remains high for a longer duration of time. Then the output keeps on toggling. Toggle means the switching in the output instantly AI. So Q equals 0, then Q equals 1 will immediately change to Q1 and Q0 equals 0. And this continuation keeps on changing. So this change in output leads to race around condition.
Can you discuss me about the flip-flop?
D flip-flop is an electronic device that knows on the delay flip-flop or data flip-flop, which is used to store single bit of data. Data flip-flops are synchronous or asynchronous. The clock symbol required for the synchronous version of D flip-flop, but not for the synchronous one. The D flip-flop has two inputs, data and clock input, which control the flip-flop. When clock input is high, the data is transferred to the output of the flip-flop, and when the clock input is low, the output of the flip-flop is held in its previous state. Circuit diagram and truth table of D flip-flop. Operation of D flip-flop. Case 1, PR equal CLR equals 0. This condition is present as an invalid state where both PR present and CLR clear inputs are inactive. Case 2, PR equals 0 and CLR equal 1. This is state in which PR inactive 0 and CLR inactive 1, and the output Q is set to be to 1. Case 3, PR equal 1 and CLR equal 0. This state is reset state in which PR is active 1 and CLR is inactive 0, and the complementary output Q is set to 1. Case 4, PR equal CLR equal 1. In this state, the flip-flop behaves normal. Both PR and CLR inputs are active 1. Working of D flip-flop. D flip-flop consists of a single input D and two outputs Q and Q. The basic working of D flip-flops is as follows. When the clock signal is low, the flip-flop holds in current state and ignores the input. When the clock signal is high, the flip-flop samples and stores the input. The value that was previously into the D input is reflected and the flip-flop's Q output. If D equal 0, then Q will be 0. If D equal 1, then Q will be 1. The Q outputs of the flip-flops is completely by the output. If Q equals 0, then Q will be 1. If Q equal 1, then Q will be 0. Characteristics of table D flip-flop. The characteristics table of the D flip-flop display the behavior of flip-flops for each combination of input and current state. The characteristics of behavior for D flip-flop as follows. D is the input, Q is current state, on +1 is the next state outputs. Q in +1 will always 0 when D is off, 0 irrespective of current state of flip-flop. When the input of flip-flops is 1, next state of flip-flops will always be 1 regardless of the current state of flip-flop.
So how about the D flip-flop excitation table?
Okay, here Qn represents the current states of the flip-flop and D represents the current input of the flip-flop, whereas Qn plus 1 represents the next state of flip-flop. When the Qn is 0 and the Dn is also 0, then Qn plus 1 becomes 0. This situation explains the coordination of hold state. When the Qn is 0 but Dn is 1, then the Qn is 1 becomes 1. This situation explains the condition of reset state. When the Qn is 1 but Dn is 0, then the Qn plus 1 becomes 0. This situation explains the condition of hold state. When the Qn is 1 and the Dn is also 1, then the Qn plus 1 becomes 1. This situation explains the condition of reset state. Okay, that's all.
So this will be the last questions I'll be asking to an IT student, and it's regarding T flip-flop. So can you discuss me about the T flip-flop?
So T flip-flop, or to be precise, is known as a toggle flip-flop because it can able to toggle its output depending upon the input. T here stands for toggle. Toggle basically indicates that the bit will be flipped either from 1 to 0, 0 from 1. Here's a clock pulse supplied to operate these flip-flops, hence it is a clock flip-flops. So basic block diagram of T flip-flops. Here's the block diagram contain a toggle and a clock input, and Q is the complement inputs. Working of T flip-flops. Case number 1. Let's say T is equal to 0 and clock pulse is high 1 than output of both and gate 1 and gate 2. Gate 2 will be 0, gate 3 input will be Q, and the similarity of gate 4 output will be Q. So both the value of Q and Q are same as either previous value, which means whole states. Case number 2. Let's say T is equal to 1. Then output of both and gate 1 will be T times clock times Q. And since T and clock both are 1, then the output of AND gate 1 will be Q. And similarity output of AND gate 2 will be T times clock times Q. Q now gate 3 output will means Q, and the similarly gate 4 output will be Q plus Q. And since Q is 0, so gate 4 output will be Q, which means 0. And Q is 0, hence, in this case, we can say that the output toggle because T is equal to 1. T is a toggle input, Q is present state input. Q plus T plus 1 is the next state output. From here, we can say that whenever toggle is 0, next state output is equal to Q, T plus 1. Is same as a current state output Q. Whenever toggle is 1, next state output Q, T plus 1 will be complement of current state input, which means it's gate toggled. So, characteristic equation. The characteristic equation tell us about that B will be the next state of flip-flop in terms of present state. In order to get the characteristic equation, key map is constructed, which will be shown as below. So, if we solve above key map, then the characteristic equation will be Q times N plus 1 is equal to TQN plus TQN is equal to TX or QN. Excitation table. Excitation table basically tells about the excitation which is required by flip-flop to get from a current state to next state. Here, whenever T is 0, QT plus 1 is same as input Q. And whenever T is 1, QT plus 1 is complement of input Q. So that's all. Thank you.